Okay, so number one, worksheet 4. Okay, so we start off with expansion. Numerator will be part of a positive log. All the denominator can be separated as part of a negative log. So expansion first step, log of 4 minus log of x squared minus log of square root of 1 minus x. And the square root of 1 minus x can be written as 1 minus x to the 1/2. Here we can keep expanding, bring the remaining exponents down. We're still in our cleanup stage here, no derivative yet. Right, so now that we're here, everything expanded. All of our u values look relatively manageable for us to jump into our derivative rule. And the rule that we're going to use is 1 over natural log of a times u prime over u. However, we can skip a step here because notice that there are no variables here. This is just a number. So that number will just go to 0. So we can just avoid having to go through all that process if we already know it's going to 0 out. This one, second term, 2 stays. Camera keeps going in and out. Okay, so now we apply our derivative rule. 2 stays, 1 over natural log of 5, 1 over ln of 5, u prime over u, so that becomes 1 over x. We keep the 1/2, 1 over ln of 5, u prime over u, so negative 1 over 1 minus x. And if you leave your answer like this, it's okay. I'm just doing a little bit of merging and cleaning up, but you don't have to. Okay, any questions with one? Okay, number 2. I will provide instructions for number 2, which is log differentiation. So first, let's rewrite using rational exponents. Okay, so this is raised to the x over 7. We know we are going to apply log. The reason that we're applying log differentiation here, besides the instructions, is you know that there is no other way to apply our derivative rule, because we don't have a rule that's in this form of variable raised to a variable. So I just want to get that x over 7 to be a little bit easier for me to work with down the road. So I'm just rewriting it as 1/7 x, just because I know that eventually when that comes down, I'll do power rule. Prefer to see it this form rather than that form. It doesn't really matter, but that's just, I think we prefer to not have to look at a number below the variable if we don't have to. So next step, take natural log of both sides. Okay. Once we're inside of the natural log expression, we're free to apply our expansion rules. We have a power property we can apply. So bring that 1/7 x down in front. But we know that as soon as that comes down, we've turned the problem into a variable times a variable. So we should be expecting product rule to show up as we think about our derivative process. Right? Okay, so this is where we want to be before we begin our derivative work. Okay, left side, natural log of y becomes u prime over u, or 1 over y dy dx. We know there's a little bit of implicit on the left side. And then we begin our product rule, f prime times g plus fg prime. 1/7 x becomes 1/7. G stays, f stays, and then we have to do our derivative process for what's inside the parentheses. So each term, we apply the derivative rule and put it up here in this u prime slot. So x squared becomes 2x. Natural log of x becomes 1 over x. So there's my u prime over u.
Yeah. When you get the derivative, that only goes away on the outside, correct?
That's right. Yeah, the derivative rule for natural log of u is just u prime over u. There's no more natural log that remains. Okay. After this is cleanup. Any questions with the derivative step here? Great. Our final step, move that y over to the right side. Get that dy dx by itself. You can leave all this mess. I think I'll do a little bit of cleanup, but you don't have to do much cleanup on the right side. Just make sure that when that y comes over, that you also replace the y back in terms of the original function in terms of x. So when that y comes over, it's going to be in the numerator, and then replace the y back with the original expression from the problem. Okay, any questions with 2? Our 3 is that chart process we're working on. We're trying to find the derivative of f inverse at 2. So We know we're trying to find the derivative of f inverse at 2. We know 2 is the x value of my inverse function, which must mean that 2 must be the y value of my original function. Now we're working on trying to figure out what that x is for that order pair. All right, so we go through our trial and error. If I test 0, 0 doesn't work. If I try 1, 1 does work. 1 plus 2 is 3, 3 minus 3 is 0, so I have my x value. So my order pair is 1, 2 on the function side, 2, 1 on the inverse side. So now that I have the location of my f function, I can focus on building the slope. If I can find the slope at that point, I can use that number to flip it to get to the slope that I'm really looking for. So f prime of x, power rule. F prime of 1, we know is 5. So if the slope of my f side is 5, the slope of my inverse at its corresponding point must be the reciprocal of number 5. All right, number 4, find the derivative for natural log of xy plus xy equals 50. A couple of things that want to make sure we are thinking about as we're working through this problem. We know there's implicit going on here, right? This is not a function where y is isolated on the left side. It's mixed into the equation, so we know there's going to be dy dx. 2 of them that's going to show up along the way. We know there's also a product rule here, that xy. And then we know there's also expansion properties that we can apply here. So we should start there. We should start with the expansion, since we want to do that before the derivative process shows up. And we're going to apply product rule here. All right, so we begin our derivative, natural log of x. That's 1 over x. Natural log of y, 1 over y, dy dx, right? We're asking for y's derivative. Product rule. Okay, f prime g plus f g prime, x becomes 1. G is y. Back to f. G prime, y becomes 1 dy dx. $50 is also getting impacted, so make sure you push that to 0. And now we're just in our cleanup efforts. Let's collect our dy dx terms on the left, move the non-dy dx terms to the other side. Okay, factor your dy dx out. Morning. Okay, any questions with 4? Page? All right, find tangent line for the equation. Here, I'm going to say no log differentiation. So we have to take our order pair, find our slope from the derivative, and then point slope form. What if I didn't give you that 0? If I just gave you x equals 1, what would you do?
Plug it into.
Yeah, good. Plug it into the original equation. That will get you your y value. Okay. Okay, so no log differentiation. What do we have to do if we want to find the derivative? Product rule. Yeah, e to the negative x. It's its own thing. Natural log of x is it's another expression. They're being multiplied with each other. We have to go through product rule. Okay, remember the rule for e to the u is e to the u times u prime. So that's just e to the negative x times -1. G function stays. F stays. And then natural log of x, remember the derivative for natural log of x is simply u prime over u. There's no more ln, just u prime over u, so just 1 over x. You can plug it in as is. I just like to do a little bit of cleanup so that I'm plugging into a positive exponent rather than negative exponent, but it's up to you. So I just merged this into one fraction. I pushed the e to the x down to the bottom. Okay, so now I have my derivative function. Replace every x with 1. You can leave this as your slope. That's fine. I just know that natural log of 1 is 0. So I'm just going to do one step cleanup here and just wipe it out. But if you don't, it's okay. You can leave all this and just have that to be your slope. I'm just going to let my slope be 1 over e. All right, so I have my order pair. I have my slope. Now point slope form. Okay, for number 6, I will provide specific instructions that this is a log differentiation problem. So you're going to take the natural log of both sides to begin the process. And the reason that we do that is because we don't have a rule that can handle a variable base with a variable exponent. Start off introducing natural logs to both sides of the equation. We know that 2x can come down using log properties.
Is that 2 to the x, or is that just 2?
That might, you're right, 2 to the x, thanks. All right, so we know that anytime we do this process, we're expecting product rule to show up. You're always going to end up with a variable expression times another variable expression. Okay, a little bit of implicit on the left side, 1 over y dy dx. Now I'll step through product rule. All right, 2 to the x, that's the a to the u rule, right? So recall the derivative for a to the u is conversion, natural log of a, then the original function, then the exponent's derivative. So the derivative for 2 to the u, 2 to the x will be natural log of 2 times 2 to the x times 1. Are you okay with f prime? All right, g function stays. F function stays. And then g prime, u prime over u for natural log. And if you leave all this derivative mess as it is, that's fine. You don't have to clean anything up. But we do have some steps that we need to take on the left side. Bring the y over to the right, and then replace the y back in terms of x.
Do we have to do that in 2 separate writing processes?
No, yeah, if you understand that the y comes over and then if you just bring that over and to convert that back to the original function, I'm okay. You don't have to show that y coming over. You jump from here to the answer.
But I understand that you put a bracket.
Mm-hmm.
Is that required for,
Wait, do I have a bracket?
or like,
Oh, here, no, I just wanted to differentiate between, it doesn't really matter. If you do a bunch of parentheses, it's okay. Just visually, that's just my preference, but you don't have to do that.
And we don't have to like simplify it at all.
No, you don't have
We
to.
can literally just write it exactly as we did.
Just careful that if you are trying to merge things together, just make sure we understand that, the 2 to the x is not free to combine with something else. You can't make this 10 to the x. Right? That 2 is not a coefficient. It's part of a exponential function. So that 2 and 5 are not compatible. We can't make that together. But if you don't clean anything up, that's fine as well. Leave all that mess with this in front is okay.
Percent part, is that 8?
Yeah, that's a to the u rule. Yeah. If I have a number raised to a variable, it's a to the u. Natural log of that number times a to the u times u prime. Yeah. Okay, any questions with 6? Okay, next up, number 7. We jumped directly into expansion. Again, no log differentiation unless I specify. So no log differentiation here. You're just working the problem the way it's shown. So expand first. We have 3 separate terms, or 3 terms that we can separate using expansion. So log of the numerator minus log of the denominator minus the log of the other denominator. I can bring that radical out as raised to the 1/2. Clean up. I'm going to bring that 1/2 down in front. Every one of these terms will apply log base a of u. 1 over natural log of a times u prime over u. All right, any questions up to this final step before derivative? Okay, so the 3 is going to stay. Log base 7 turns into 1 over natural log of 7. U prime over u, so that becomes 1 over x. 3 stays for the second term, 1 over natural log of 7. U prime over u, the derivative for e to the 2x is e to the 2x times 2 over u. U is the original function, so e to the 2x. If you don't want to cancel out, you don't have to. I just saw a chance to cancel out. And the last term, 3 stays. 3 and 1/2 stays. I made it 3/2 after the 1/2 came down. Log base 7 becomes 1 over natural log of 7. And then u prime over u. Power rule for the parentheses becomes negative 6x over 1 minus 3x squared. If you leave your answer like this, I'll give you full credit. I just clean it up a little further, but you don't have to.
You don't have to call something.
Right, you don't have to pass out.
Assuming, what is the derivative rule when you're finding e to the 2x?
Yeah, so the derivative for e to the 2x is e to the u times u prime. So the derivative for e to the 2x is itself times the exponent's derivative.
So
So
why is it over?
why is it because the ln?
Because yeah, this is because within this, the larger rule is log base 7. So log base 7 is 1 over natural log of a times u prime over u. And the u prime
Oh, I see.
has to live in this numerator location.
So in that formula, u prime is the whole.
That's
e to the
right.
2x, not just.
Right, it's
Yeah.
it's within this e to the 2x, the u is that, but within the larger problem, the u value is e to the 2x.
You would still get partial credit if you forgot that part, right?
Yeah, yeah. I'm not. It's not all or nothing. I'm trying to give as much points as I can based off of what you can show me correct. Okay. Any other questions? Oh, I just simplified. I made 6 and 2 to become 3, and then 3 times 3 is 9. But you don't have to. I just merged all the coefficients together. Yeah. Okay. Number 8. Okay. Any other questions with number 7? Right, so this is one of those problems where we know there are multiple things that we have to consider. Implicit, because all the y's. Expansion property, because that natural log with terms inside of it. And then we also have product rule that we have to worry about for derivative with that 3x squared times y. Okay, let's start off with expansion. So I'm just basically cleaning up that first term all the way out. Or first and second term all the way out. Yeah, so I encourage you to not stagger your process, meaning that some students would do this. They would clean this up, but then begin the derivative on this side. So try not to begin the derivative until every term is ready. And it just makes it easier. When you're going back to double check your work, it's easier to read your problem when you're not doing different things on the same line. So the right side, I'm just recopying over and over again. I know it just feels additional work, but it's worth the effort just so that you're not easier to make sense when you're looking back at your work.
Mr. You will work setting all setting to the left side instead of 0.
No, I mean, eventually, you could at the beginning. I just build the derivative as it is, and then at the end, then I move everything over. I think so, but that's really up to you.
Won't you still end up with an xy? Because the derivative of 3x squared is 6x times y.
Well, it's product rule, right?
Yeah.
So there's more to it than that,
Okay.
right? I mean, we do have 6x and y show up.
Yeah.
But there's more to it, right? So we can't just stop there. Okay. All right. Any other questions before we do our derivative process? Okay, so now ready for each term. We know there's implicit. We see 3 y variables, so we're ultimately expecting 3 dy dx to show up. 1/3 natural log of y becomes 1/3 1 over y dy dx. 5 natural log of x becomes 5 times 1 over x. spell out my product rule for 3x squared y. So I have my f prime g plus f g prime. F prime is the derivative of 3x squared, which is 6x. We keep the y function. Back to f, 3x squared, g prime, y becomes dy dx. So now we're done with product rule for that 3x squared y. Okay, we keep going. Minus y becomes minus 1 dy dx. 5x becomes 5, and that 3 drops out to a 0. All right, so this is the most important step here. This is the calculus step from here to here. After this is just cleanup. So any questions with this step here? All right, so now our cleanup stage. We have three terms with dy dx in them. We're going to add and subtract in a way where we can collect all of our dy dx terms on the left. On the terms without dy dx, we're going to move over to the right side. Then we can factor out our dy dx on the left and then divide all that over. And then within each of the numerators and denominators, if the order is different for you, it's fine. As long as you have the correct 3 terms in the numerator, correct 3 terms in the denominator, it's good enough for your derivative.
So there's all the dy axis on one side.
Yeah, move all the dy dx to the same side. I like to move it to the left side, but you don't have to. That's just my preference. Also, if you collected all your dy dx terms on the right side and move everything on the left, everything in your answer will be the opposite sign, which is fine. It will get negative 6xy minus 5x minus 5 all over negative 1 over 3y plus 3x squared minus 1. If all your signs are different, it's the same. It just means that you collected your dy dx terms on the other side. All right, any questions? Okay, you guys want to practice your derivative rules? We know these are related. This will just be an extension of this rule, and that a to the u is an extension of this rule in a way. I'm sorry? Yeah, just anywhere you have space. Okay, check your rules. Hey, let me know if you have any individual questions. All right, see you. Oh, for practice. That one that's happened over. Hey.
I have a question. So what's this log differentiated? And when we first use that, that's just product rule. Like you want to see
Wait, say it again.
what it says. Like some say you have to use log,
Log
That-
differentiation,
which means product rule.
which means take the natural log of both sides.
Actual log. Oh, okay, wait. So
Log differentiation is when you introduce natural log into the problem.
so it
that-
means there's no log. There's
That
no,
means, yeah, there is no logs. But on the quiz, I will specify, use log differentiation here, don't use it here. So I'll specify.
Okay.
When to
so like the last one's non-log differentiation.
right, log differentiation, what you're gonna see is, it'll be like this. If I have a variable raised to a variable, I'm gonna tell you to use.
Right, because there's no log in there.
There's no
And
log, and also there's no rule that we can use.
Right. Okay. Okay. Thank you. And then there's a on top of the worksheet or the practice, there's a oh yeah, there's a rule. I only use it. It's the what's it called? It's like n minus or n to the power of negative.
Oh, that's it now.
But we're never gonna.
No, we have.
Oh, we have. Okay.
Yeah. I mean, you've used it so much.
It's always on.
Yeah, you don't even think about it. It's automatic.
It's like that.
2x is 6x squared. You already know.
Oh.
That's power.
Okay. Thank you.
Because they're above each other, they're being multiplied. It's like 2/2. I can't. But you don't have to multiply it. Okay, so the reason I took the problem is because we're the lower we're working with this log base. So, log there's the U prime, but there's a larger rule here. The larger rule is log base A of U. Right, okay, the log base A of U becomes 1 over dash log of A. So I'm going to remove this. Becomes 1 over ln of 7 times U prime over U. Or that U value. So the each of the 2x, it's its own rule, it's gonna live up here.
Now if it was, say, 2 to 2x, then you have 2 to x times.
Yeah, it was this.
So. That will be there.
Right, 1 second, let me set something.
Because there's a log here.
There's a log there, so we have to build the
It's a big-
outside,
yeah,
it's a bigger
outside,
rule.
yeah.
Yeah, outside.
And now if it was just. Would we be given something where it's like 2e to the 2x?
Yeah.
Good.
Mhm.
Okay, so then this would be natural log 2.
No. Remember, each of the U has to go in that log.
Is that not a to the u?
There's not
Oh,
a,
'cause-
right, if it was 2 times 2 to the 2x, then you can use that a.
So then that'd be just 2 times natural log 2.
Remember, the derivative for each of the U. It's just itself.
No, that's right, but that's a to the u. So
Oh, okay, are you
Yeah.
talking about this
A,
problem?
yeah, a.
Yeah, so this one, it'll be 2 times.
Natural log 2. 2. Yeah. It's just an extra side.
That's a. Yeah, that's a lot.
Question. Was this problem, did you tell me, I think I came so at the time when you
Mhm.
started it,